How's it going, guys? I hope the law of cosines work wasn't too bad. Just chilling here in the backyard, about ready to crank out another video for you guys. Remember, let me know if you're struggling with something. Just send me a quick email. If the homework doesn't make sense, you need help with a certain problem, I can even make a little video and send it to you, or just talk with you, FaceTime or something. We can figure something out. So let me know, and I will go ahead and get started on that. And the thing I want you to focus on today with the law of sines is I'm just going to start getting you prepared for the whole ambiguous case, which we're going to do the next video. And the ambiguous case, and I've mentioned it once with the law of cosines material, every now and then you'll get a situation where you'll be giving information, you'll be trending towards using the law of sines, and then all of a sudden you'll realize that the given information could actually result in either A, not even having a triangle, or B, it actually fits two different triangles. Now today you're not going to have to worry about that. Today we're going to stick with law of sines. We're going to use law of sines in the situations that law of cosines doesn't work super well for us starting out, and you're going to see it's not so bad. And but I'm just going to go ahead and start warning you about situations that occur. We call that the ambiguous case, situations that occur with law of sines that could get you into trouble. All right, so special attention to that. Good luck at, can't talk. Good luck with your classwork and homework, and we'll see you guys next time. Here you go. Okay, here's the law of sines for you. I've gone ahead and just written it out. The bottom line is we're not going to use all three parts at once. You will only use two of the three fractions in an equation. So it's really kind of a short way of writing out the three different law of sines. The first one being sine of A over A equals sine of B over B. Second one being sine of A over A equals sine of C over C. And the third one being sine of B over B equals sine of C over C. So again, you're going to use whichever two parts that, that the information you're given fits into, and then just go with it. Now, if you think about it, I'm going to go ahead and draw a picture, and I'm going to show you a quick proof. If you want to skip over it, you can, although I don't encourage you to. But anyway, if I had this labeled A, B, and C, and this is side A, and this is side B, and this is side C, I'm just, for now, just going to circle two of these parts. Okay, now think about what I'm given here. In order to be able to solve using the law of sines, I would either have to know angle A, angle B, and then one of these sides, right? Or I guess I could know angle A, angle B, and the other side. Or I could know both sides and one of the angles, say angle A, or both sides and the other angle. All right, now that's assuming that I was going to try to plug stuff into here. Now, if you look at all these situations, this is an angle connected to an angle connected to a side. All right, now that's two angles and a side. We could call that situation AAS. This right here is a angle B, connected to an angle connected to a side. That also is an AAS. Now you could call it SAA, but whatever. Bottom line is you have two angles. And here's the thing. If I'm ever given two angles, what do I also know? Well, real quickly, I could take 180 degrees, subtract the two angles, and then I would know angle C, right? And if I know angle C, what I really have is all three angles. And you could call that angle, angle, angle side, or angle, angle, side, angle. It doesn't really matter whether I call it that or that. Bottom line, if you ever know two angles, you know the third. Okay? So bottom line, if I'm given two angles and a side, I definitely can use law of sines, because I can take those two angles, plug them in there and there, or even if I know B and C, I could plug them in there and there. But I just let A be the driving factor there, because I have to use sine A over A because I was given side A. Just like over here, I would have to use the sine of B over B because I'm given side B. All right? So definitely when you're given two sides and an angle, I'm going to want to use law of sines. And by the way, you can't even use, when you're given two sides and an angle, stuff like that, you can't even plug that into the law of cosines anyway, because in the law of cosines, there's only room for one angle. All right? So the other situation is what happens when you have two sides and an angle. Now, a lot of people accidentally look at these two sides and an angle and think, oh, it must be side, angle, side. Not true. Remember, if you look at this, this is A and this is B. If I'm given angle A is not the included angle. I can only do side, angle, side when I have the included angle, and I don't have it. So this is what we call a side, because it's a side connected to a side connected to an angle. This is what we call side, side, angle. All right, and also I could have B connected to A connected to B, right? Side, side, angle. So both of these are considered side, side, angle situations, and we can get in a lot of trouble with side, side, angle if we're not careful. And we'll start talking about that today. But today's homework, you're not going to get into trouble. I'm only going to give you situations where side, side, angle, or angle, angle, side works really nicely with law of sines. Okay? Now, where did this formula even come from? You know, the next, or actually in a couple of videos, we're going to be talking about area, not just an area of a right triangle or an area when you have a base and a height, but what happens when you're given sides and angles and I need you to find area and it's not a right triangle? Well, we're actually going to learn a formula. You're actually going to see a little mini proof of it right here. And it starts out much of the same way we started out with law of cosine. So I'm going to draw a triangle here that is not a right triangle. I'm going to call this angle A. I'm going to call that angle B. I'm going to call that angle C. Okay, and this is a y and x axis right here, okay? So there's the x, there's the y. And what I need here is this coordinate again. And this time I'm not going to do a distance formula like I did with the proof of law of cosines. I really just need this height. So I really don't even need the point. I just need that height. Okay, so I'm going to draw this little altitude right here, and I'm going to call it h. Right, and remember, if this is angle A, that's side A, right? And if this is angle C, this is side C. Now, what I want to do is find out what this height is, given that I know that angle and this side. And remember, I'm drawing this little triangle here. I really don't know that angle because the whole part's B, so I don't know that part. I don't know this side right here, right? All I know is this side and angle A. So what could I do using angle A and that side and that height to find h here on this triangle? Well, if I was solving for h given those two things and I know it's a right angle, I could say, oh, the sine of A is the h, which is the opposite, over the hypotenuse, which is the c, and then real quickly I could multiply by c, and that is my height. I don't know exactly what it is because I don't know c and a, but that would be a formula for it. Now, with this in mind, if I know the height, can't I find the area of this whole big triangle? Because we know the area is 1/2 times the base times the height. And I know that the base is the entire side, which is side B. So the whole side that we call the base is B. So I'm going to plug a B in there. And then the height we just found is C sine of A. So what I just found out here is that area of this triangle is 1/2 BC sine of A. Now think about this for a second. What do you think would happen if I took the ABC and instead labeled it CAB? Would I get the same equation doing the exact same proof? No, I would get another equation. Instead of having sine A in there, I would get another equation that is 1/2. If I move the C over, I'll end up with AB sine C. And if I do it again, I move it over, I end up with AC sine B. And I'd end up with these three different areas for the exact same triangle. Well, if they're all the same area, just different ways of finding it, couldn't I set them all equal to each other? Now, guys, again, you are not going to have to do this. on your test. I'm just trying to show you in case you're curious. So if all of these are the area of the exact same triangle, that means they're all equal to each other. What would happen if I took this area equation and divided everything, remember in algebra, as long as I do it to all three parts, I'm okay. If I divided them all by a half and then also all by ABC, and then started canceling stuff. The 1/2 cancels, the B's cancel, the C's cancel, and what do I have left? Sine A over A. What happens here? 1/2s cancel, A's cancel, B's cancel, sine C over C. And what happens here? A half and the A and the C cancel, and I'm left with sine of B over B. So in case you ever wonder, that's where the law of sines comes from. It's basically an area formula. And when we go start learning area, I might quickly remind you of this, but in the interest of time and not boring you with video, remember that this is one way to find an area formula, and these will be the area formulas, believe it or not, when you're given side, angle, side. Because think about it, I have two sides and a non-matching included angle, right? AB, remember AB with angle C is the angle in between? So it's side, angle, side when the angle doesn't match the two given sides. So whenever you have side, angle, side, and you're looking for area, we would use this, but this is the law of cosines that we're going to be using today. All right, and once again, when are we going to use it? We're going to use law of cosines whenever it makes sense, which is when I'm given two angles and one side, and that could be an ASA or an AAS, doesn't matter, because if I know two, I can always find the third. And then the second situation is when I have side-side angle. And if I didn't mention this already, side-side angles are really easy to notice because on side-side angles, unlike side angle sides, there will be a matching side and angle. Let me go back up and show you. These two examples were not SAS. Look, but there was a match of A with A or a match of B with B. So if you ever have two sides and an angle that's not the included angle, you'll see it match. And you're gonna know, oh, right away, that's a side-side angle. Let's use law of sines instead. Okay, so that's the setup. That's really all there is to it, but let's talk about how to apply it. So I'm gonna do 2 or 3 problems. It's really all I'll need to do because after that, well, maybe even 2, I'll just kind of get you going. But I want you to know something. You can't start using law of cosines with these situations, okay? You can't do it. So actually, sometimes you can, but it makes your life miserable. So if you ever are given SSS or SAS, you want to start with law of cosines. If you're given ASA or AAS, those two, or even SSA, you want to start with law of sines. All right, and then once I use that law of sines, I'll talk about maybe what we could do after that to find the remaining sides and angles. Okay, so the first problem we're going to look at is going to be this one. So problem number 1, what would happen if I told you that angle A was 22 degrees and that side A was 10, okay? And let's go with side B is, how about, let me think for 1 second. I don't want to get us in trouble. What about side B is 7? Okay, so let's look at a situation like this, and I'm even going to sketch a picture of it for you. Okay, so you don't have to do this, but once we learn the ambiguous case, this will kind of make more sense why I'm doing this, and we're going to learn that next. Not today, but next video. So let's just draw this 22-degree angle. Now, when I draw a 22-degree angle, I don't know exactly what it looks like, right? I'm just going to say that's angle A. You know, it's a little bit smaller than 30. It's probably a little bit too big, actually, like this, but whatever. Now, when I draw the angle, I really don't know anything about the sides, right? So I'm going to go ahead and put dotted lines here, indicating that this angle just kind of goes in both of those directions. Now, where would side A be? Side A has to be opposite angle A, so it has to be somewhere over here, but I really don't know how to draw it yet because I don't know where to begin it on each of these arms of this angle. But side B would be opposite either angle B if it was up here, or maybe opposite angle B if it's up here. So I'm going to pretend like the angle B would be up here, And I'm going to draw side B down here, and I am just going to say that that is 7. So this side B is 7, and I'm going to put little dots at the ends there to kind of emphasize to you. I'm even going to, just for good measure, liquid paper all those little dots out right there, or whatever you call this, whiteout. So that's side B, and that's the length of side B. Now side A is 10. It's a little bit longer than that. So think about it. You're going to actually have to sketch in 10. There's no way that it could be here in there, because if I draw it there, then side A, which I know is opposite A, this would be smaller than B, right? If I draw this, it looks like it's more like 5 or 6 or 4 or 3 or something like that. So to be 10, it's going to have to go way up here to have a shot at being 10. Okay? So this is the kind of problem you might see tonight. So you don't have to draw a picture of that, but this is what you're trying to do now, is figure out what this angle B is up here, what this side C and what this angle C is. All right? So the first thing I look at is I go, wait, this is 2 sides in an angle, but there is a match. And if there's a match, it's not SAS. This must be SSA. And when it's SSA, I'm going to use law of sines. Okay? So which law of sines am I going to use? Which parts? Well, I've got to use the A and the A, right? So, because I'm given that. So sine of A over A. And since I'm given B, it sounds like I've got to use the sine of the B over the B. Now, you don't have to write that out. You could just go straight to saying sine of 22 over 10 equals the sine of angle B over 7. All right? Now, your job at this point is just to solve for B. So what I'm going to do is multiply both sides by 7. That's going to cancel out that side. And I'm going to type all of that into my calculator. And again, hopefully you have an Inspire, but I'll show you both ways. If you have an Inspire, to type this in, I'm going to make a fraction, and I'm going to say 7 times, hopefully you can see this, trig sine of 22, and I'm going to divide it by 10, and that's going to give me some decimal answer. So 0.26222. I'm just going to write out, and then I'm going to drop down sine of B. All right, so I'm going to write that down, and then when you look at this, I'm going to inverse sine your B. Inverse sine both sides. So that will get rid of it here, leave you with just B, and you don't have to put angle B if you don't want. I always get in the habit of doing it there. And then I'm going to write inverse sine of that. Now, again, somebody asks me every year, do I need to be exact? Absolutely. And also, if that ends up being negative, should I change that to a positive? Well, here's where you're going to run into trouble with sine. Okay, sine, law of sines, when you do an inverse, it is not able to ever give you a negative answer. I'm sorry, an angle bigger than 90. Because we're going to talk about this more next year, but the inverse sine graph is only defined between negative and 90 and positive 90 degrees. And of course, there are not any negative angles on this triangle. But if there is an angle, like angle C, for instance, kind of looks like it is not acute, it's obtuse. And if that's the case, I can't use my information here. I can't use law of sines to find angle C without some extra careful measures. So as long as I am finding an angle that's not possibly obtuse, I'm okay. And if I look at this B, I know, think about this with me for a second. I know that angle B can't be obtuse because the total sum of the angles is 180, which means if one of them's obtuse, like if one of them's bigger than 90, the other two have to be less than 90 total. And B is clearly not the biggest side here. A could be the biggest side, but I'm not solving for angle A, am I? And I'm sorry, and we know that angle A, by the way, is not the biggest side because side A is not the biggest side because look at angle A. Angle A is 22 degrees. Well, that tells me that angle B, since it's a smaller side than side A, angle B must be even smaller than that. And you can kind of see that based on this picture. But anyway, I want to finish this up now. I want to take the inverse sine of this 0.2622. So I'm going to go trig And I'm going to keep saying what I said, by the way, to make sure you're good. Inverse sine, I'm going to go control answer to bring down, I'm going to do inverse sine and then control answer to bring down that value so I don't have to retype it in there. And then I get 15.2 degrees. So sure enough, angle B did end up being smaller. Today I'm going to round to the tenths place, and you just follow the directions on the test. But I get 15.2 degrees. You can see that it's smaller than the original angle A, which you had a good idea about. But something that I'm going to keep repeating over and over again is never use law of sines to find the biggest angle unless you absolutely have to. And that's what the ambiguous case is about. And sure enough, we know that angle B is not the biggest angle because side B is not the biggest side. So I am totally comfortable using law of sines to find that. And then at this point, what do you do if you're given, now if you already have these two angles? Well, it should be no problem to find angle C by going 180 minus the 22 and minus the 15.2. Again, I'm going to always be exact and use my exact value there. All right, so back up to this. I'm going to say 180 minus the 22 minus second answer or control answer, and I get 142.8. 142.8, which in this case, since there's only one rounded value, that's going to round appropriately. You could have just typed that in. And then right now I have everything but side C. So what do I do now to find side C? Well, you have tons of options. Again, my only worry about law of sines is using it to find the biggest angle. I don't have any worries finding sides. But if I wanted to resort back to law of cosines, I can totally do that too, right? I know two of the sides. I know all of the angles. Either way, most people would probably say, you know, law of sines is a little easier to find C. So most people would say, all right, sine of the new angle C. Now I'm going to be exact right here. 142.8 is what I'm going to write here, but I'm going to be using 142.79790, blah, 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 the exact value. So I'm going to put that angle C in there and then side C on the bottom. And then now you can pick anything you want. Now I got to be honest with you. I can use angle B, but I would rather use angle A because it was given to me. So I'm going to do that. I'm going to put the sine of A here, 22 degrees, over the side A, which is 10. And that way I don't have to worry about going back up there and finding the exact value of that 15.2. I can just use the given values. These were both given. Okay, so all I have to do now is find side C. So a lot of people like to cross multiply, and that's totally fine right here. Okay, so to cross multiply, I get 10 sine 142.8. And then when I cross multiply, I get C sine of 22. Don't put the C with the 22, leave it out there in front of the trig function. And then all I got to do now is divide by the sine of the 22. Now, when I'm done, I'm left with this. Now I want you to take a look at what I have here and see if you remember some way I could have done this without so much algebra. And I'm hoping you remember the slide rule. Now remember, it's a made-up rule that I had, and I said basically you could slide the C up. And when can you do this? When you have a fraction equal to a fraction. So I'm going to slide the C up. Now it's on top. I'm going to slide the sine of 22 down. Now it's on the bottom. And I'm going to slide that 10 up, and it's on the top. And if you look at what I have right here, it's exactly what I have right here. So to me, rather than write all that, I'm going to do some slide rule action. I'm sliding that 10 up, that's gone, and there's my C equals. So all I have to do at this point is type all of that in my calculator. So back with the Inspire, make a fraction, 10, trig, sine. I'm going to go up there and do the exact 142.79. 79, right? Or even better than that, since that's the last thing I did, I could go control answer, just pop it in there. And then on the bottom, I have sine of 22 and trig, sine, and I can just plug the 22 in there since that was exact. And I hit enter, and there's my 16.1. So side C was 16.1 units. And that's everything I needed, right? I found both angles, and I found the extra side. And at that point, we could call it a day. And that's what I'm going to do when I'm given side-side angle. All right? Now, the only other situation, and if you feel totally comfortable right here, I've kind of done both kind of situations. You're welcome to jump into the homework. But right here, I want to just do maybe one more. And I'll just, before I close, maybe emphasize to you guys that, again, do not use the law of sines to find the biggest angle unless you have to. And we'll talk about the have to next. I mean, not this video, but the next video. All right. So, and remember, you're totally fine reverting back to the law of cosines after the initial step. So once I initially use law of sines, like I did right here, all right, once I initially use law of sines to find that, once I have that, if I want, and then I go ahead and find angle C, if I wanted to, now that I have AB and sine C, AB and angle C, I could use law of cosines if I wanted to. Most people just feel comfortable sticking with sines and being careful. All right. All right, so next one, I'm going to give you a angle, side, angle situation. All right, and whether I give you angle, angle, side, or angle, side, angle, you're roughly going to be doing the same thing. So, all right, here's example 2. Let's just say that I told you that angle A was 36 degrees and angle B was 97 degrees, but I give you side C is 12. Now, a lot of people look at this and they go, wait a minute, you can't plug that into law of cosines. I would absolutely agree. And then they look at this and they go, wait, you can't plug that into the law of sines either because you don't have a side that matches an angle. And initially, and what I'm saying there is, if you think back to this formula that we had for law of sines, basically, if I give you angle A, and then I give you angle B, but I give you side C, that would force you to use all 3 parts. And you're right, that doesn't make sense. I can't use all 3 parts or I'm going to be missing 3 variables, right? But remember, even if I give you a situation like this, which by the way is an angle, side, angle, because nothing matches, right? And you could draw a picture of that and see that. If I know 2 angles, what do I always know? I know the third, or I can find it. So very quickly, I can find angle C by subtracting 36 and 97 from 180. That shouldn't be a big deal. A lot of you can do that in your head. I just want to make sure I'm not going to make a careless error that kills the rest of my problem. So 47 degrees would be my angle C. And now that I have angle C, now I have a side and an angle match, right? And if I have a side and an angle match, I'm in great shape for using law of sines. So we said anytime you have 2 angles and a side, you can use law of sines. That is definitely true. Law of sines, here we come. Okay, so let's see if we can plug this in here. I definitely have to use the sine of C over C part, but it's your call on whether I use the sine of A over A and the sine of B over B. Now, remember, law of sines will never give you issue finding sides. It will only give you an issue if you use it to find the largest angle. Well, I've already got my angles, so I'm totally not worried. I can use whatever. So I'm going to start with angle A and go sine of A over A, and I'm just going to plug everything in. You do not have to write that step. You could jump straight to the sine of 47 over 12 equals the sine of 36 over the A that I do not know. And at this point, what do? You can cross multiply like I did before, then divide and solve, or you can slide the A up, slide the sine of 47 down, and then slide the 12 up. And you're left with A equals 12 sine of 36 degrees over sine of 47 degrees. Try to remember to put those degrees on there too. So all I have to do is type that in. So, fraction. I like the fraction. If you don't have the fraction, I'll tell you what, if you don't have a fraction or if you're using a different calculator, I'll pull out my cheaper calculator right here just to show you. Still not a big deal. Just turn it on, clear the junk. 12 sine 36. Make sure you close the parentheses. If you don't, you're going to be dividing the 36 by sine of 47 as opposed to the whole thing. All right? So got to have that parentheses closed off there. Then divided by sine 47, close the parentheses, and you're going to get 9.64, which since we're rounding to the tenths today, 9.6. And that would not be degrees, that's a side, so those are units. All right, and then real quickly, I can do the same thing again. By the way, don't, for the love, take A and C now and use the Pythagorean theorem. Why can't I do that? Because this is not a right triangle. So don't make that mistake on the test. It's certainly, if it's multiple choice, that will be an option for you suckers out there that didn't really watch the videos or whatever. But definitely no Pythagorean theorem when you don't have a right angle, and I don't have a right angle. So I'm going to have to just go back and use the other law of sines, sine C over C, but this time I'm going to use sine of B over B, right, to find sine B. And by the way, if you're thinking, why don't you use sine of A over A? You've got those values now. Well, I could, but since I've had to find A and it's a rounded value, in fact, I really rounded it down there. It's really 9.64. So because it's a rounded value, if I use sine of A over A, I'm bound to make my answer off a little bit. But since angle C was not even rounded when I found it, and then I was given side C, this seems like a safer bet to me. So here we go. Sine of angle C, which is 47, over side C, which is 12. All right, and that's equal to the sine of angle B, which was given to me, over B that I do not know. And again, you can cross multiply, but I'm going to slide the B up. It'll end up on top. I'm going to slide the 12 up to be with the sine of the 97 degrees. Again, try not to forget the degrees. And then I'm going to slide the sine of 47 down. All right, and again, if you don't see how to do that, or if that slide rule's freaking you out, cross multiplying gives me this, right? And then dividing by sine of 47, guys. My little slide rule, we're not talking about a life-changing maneuver here, right? And there's my B value right there. We're talking about saving a couple of seconds. All right, some people like to do it because a lot of people don't even like showing all their work. I'm not even going to see your work on this test. All right, you're going to be typing these in as multiple choice questions. Okay, so here we go. I'm going to use the cheap calculator again for those of you that have these. 12 sine 97 and the parentheses divided by sine 47 and the parentheses. And that gives me 16.3 if I'm rounding for side B. And at this point, I've got my B, 16.3. I've got my side A, and I found angle C right off the bat. So those are the three pieces of information that I didn't have. All right, guys, do the best you can. You probably have a word problem or something like that. But before you go, I just want to show you one little thing and show you how you could get in trouble. And this is what we're going to talk about when we get to the ambiguous case. So what would have happened if I gave you this? Angle A is, say, 30 degrees, right? And then I give you side A is 10. And then I tell you side B is, say, 20, okay? And here's my question to you. When you're looking at this situation, tell me what you know about angle B. And you're not going to have anything on this on your homework. I know because side B is bigger than side A, angle B has to also be bigger than angle A, doesn't it? All right, and by the way, if you're looking at that and going, wait a minute, it's a 30, 60, 90. No, you don't know that because you don't know about angle B and angle C. It could in fact, this is totally not a 30, 60, 90. Actually, hold on. Yeah, it's totally not a 30, 60, 90. Okay, so if I had a situation like this, here's what my big question for you is. Is angle B bigger than angle A because side B is bigger than side A? And the answer is yes. So my second question is, well, then is angle B acute or obtuse? And the final answer is you don't know. So is it possible that angle B is an obtuse angle? And if it's possible, that's the ambiguous case. And if it's possible, that's what we're going to talk about in the next video. It seems a little tricky at first, but I'm going to show you ways to navigate that and to never run into issues. But we'll do that next chapter. All right? All right, good luck on your homework. Talk to you guys soon.